Alright guys, let's get some practice with solving exponential and log equations. The homework assignment tonight is to go through extra practice numbers 1 through 10. So we'll knock these out pretty quick. One of the fun things about doing exponential functions and having to solve them is we know a couple of shortcuts. One of the ones that we've recently explored is when you have like bases. So 5 is my base here. And then on the other side, 5 is my other base. When my bases are like, I can take my exponents to solve them. So in this case, 2x plus 4 equals 5x minus 8. I'm going to get my x's on one side, on this side, and I'm going to get my constants over here on this side. So I'm going to subtract 2x from both sides, and I'm going to add 8 to both sides. 2x minus 2x is 0. 8 plus 4 is 12. 5x minus 2x is 3x. 8 minus 8 is 0. I'm going to divide both sides by 3, and I get x is 4. For number 2, the problem immediately starts out with bases that are not alike. So here it was very simple for me just to take the 2x plus 4 and the 5x minus 8 because both of my bases were 5. But here I have a base of 4 and here I have a base of 8. So I'm going to have to break 4 and 8 down to 2. 2 squared is 4. In other words, 2 multiplied by another 2. That will get me to 4. And then 2, if I have multiply 3 of these together, 2 times 2 is 4, 4 times 2 is 8. So that gets me to my base. So here I will have 2 squared, and here I will have 2 cubed. 2 squared times 2x minus 1, or raised to the 2x minus 1 power, equals 2 cubed raised to the x plus 2 power. So now I have like bases, and I can do exactly what I did before. I have 2 parentheses 2x minus 1 equals, then over here I have my exponents are 3 parentheses x plus 2. So now we'll distribute and solve. This will be 4x minus 2 is 3x plus 6. You're going to subtract 3x and add 2 from both sides. Okay, so 4x minus 3x is just 1x. 2 minus 2 is 0. 3 minus 3 is 0. 6 plus 2 is 8. So x is 8. Number 3. Not even remotely close to being the same bases. 3 and 5 are going to be really challenging. 3 squared is 9, 3 cubed is 27, and so on. We're not really going to get a number like 25 or 125 or 625, which is 5 squared, 5 cubed, and so on. So what to do here? Well, we remember from our homework last night that this is written as b to the x is y, or y equals b to the x. An equivalent to that is x equals log and base b of y. So if this is b to the x equals y, that means y is 5, x is x plus 3, and b is 3. So we're going to take these variables and substitute into our equivalent. So log b is 3, y is 5, and x is x plus 3. When you put log in base 3 of 5 into your calculator, that equals 1.465. And that equals x plus 3. You're going to subtract 3 from both sides. And x is approximately negative 1.535. And that'll be your final answer for that. 4, 5, and 6 work the exact same way. So I have 1/5, and I raise it to the 3x minus 2 power. And that equals 25, raise it to the x power. And then instead of writing out the square root symbol, I'm going to write out what the equivalent would be, which is raise it to the 1/2. We do not have like bases, so I can't just take my exponents, but we're going to try to make the bases like one another. So 1/5 and 25 here. That's going to be a problem for me because this 5 needs to be up in the numerator. Right now it's in the denominator. To switch this 5 from the denominator to the numerator, I need to use a negative sign. So this exponent will need to turn negative. So 5 to the negative 1 power, which is the same thing as 1/5. These are the exact same thing. Then raise it to the 3x minus 2 power. That equals, and then the square root of 25 is just 5, and you've got x up here. Okay. Now we're ready to, now that we have like bases, we can scoop out your exponents and set them equal to one another. So you're going to have negative 1 parenthesis 3x minus 2 equals x. Distribute that negative sign to get negative 3x plus 2 is x. Add 3x to both sides. You get 4x equals 2. When I divide both sides by 4, I have x is equal to 2 over 4. Another way to write 2 over 4 is 1/2. X equals 1/2. Okay, number 5. 12 times e, raise it to the 1 minus x power, equals 500. Again, not like bases, not going to happen on like bases. So I want to isolate e to the 1 minus x. I want to get my variable by itself. I'll divide both sides by 12. I get e to the 1 minus x, now that 12 is canceled. E to the 1 minus x equals 500 over 12. Another way to write this, if this was b to the x equals y, then an equivalent way to write this is x equals log base b of y. So e is your base, x is 1 minus x, y is 500 over 12, and we're going to substitute into this formula just like number 3. So x is 1 minus x, b is the letter e, variable e, and then y is 500 over 12. Alright, log and base e of 500 over 12 is, on the calculator, 3.730. We're going to have to subtract both the x and the 3.7 so that we can solve for x. So x needs to be positive, and we'll subtract the 3.730 from each side. Alright, x minus x cancels, 3.7 minus 3.7 cancels, and I'm left with 1 minus 3.7 and then equals x. So x equals 1 minus 3.7 is going to be negative 2.730. And just so we can see that and it's very clear, I'm going to write it over here. X equals is about negative 2.730. There's a final answer on number 5. Number 6 works the exact same way. You want to get your like bases, so I'm going to add 14 to both sides. And I get that 3e to the x is 25. I can divide by 3, and I get that e to the x is 25 divided by 3. So b to the x equals y is the same thing. Like, another way to write this is that x equals log in base b of y. So we're going to match up our variables. B is e, x is x, and y is 25 over 3. So log in base e of 25 over 3 equals x. When I type this into my calculator, log in base e of 25 over 3 just equals 2.120. And that equals x. 2.120. Let's work on 7, 8, 9, and 10.